Now dear student, we are going to discuss question number 8.2, and in this question again we have 4 parts A, B, C and D, clear, and now we have to check here that which one we have a correct alternative, clear. So first we are going to discuss here part number A, so concentrate on the screen. Acceleration due to gravity increases or decreases with increasing altitude, clear. So now we can say, if I am talking about acceleration due to gravity, clear. So let's suppose initial I am assuming we have a earth, and let's suppose we are placing any object at a surface of a earth, clear. Now what I am doing here, actually I am now lifting this object from a surface of a earth to a certain height, clear, and I am actually assuming here, let's suppose I am saying the height that is very less compared to radius of earth, clear. Just I am assuming, clear. At that time I can say this G dash, this is given by G1 minus 2h upon Re, clear. You can also write a general expression like this, that acceleration due to gravity due to variation of a height, this is given by G1 upon 1 plus h upon Re, clear, and we can say this is whole square. Clear to you? Yes, clear. So from here you can say, if we are increasing height, clear, statement is given to you, acceleration due to gravity with increasing altitude. So we can say when h is increasing, it means this factor is increasing. When we are subtracting from 1, it means definitely this factor is decreasing. So I can say acceleration due to gravity decreases, clear. You can also see here, if we are increasing here h, definitely denominator increases. When denominator is increases, it means I can say this value of G dash decreases, clear. So what is the correct option we have? Correct option here we have, that is acceleration due to gravity decreases with increasing altitude. Clear to everyone? Now if I am talking about part number B, in part number B it is given to you acceleration due to gravity with increasing depth, clear. So now you know definitely that acceleration due to gravity due to increasing depth, this expression is given by G1 minus D by Re, clear, where we are taking this D from surface of a earth, clear. You can say like this, let's suppose here we have this earth, clear. Let's suppose this is initial position, I am taking this body at a certain depth D. Let's suppose this is center O, clear. Here we have radius Re, clear. So at this position, if I want to find what is value of acceleration due to gravity, I can say this is given by G1 minus D by Re, clear. So now we can say as D is increasing, it means I can say depth is increasing, clear. So when depth is increasing, it means I can say this acceleration due to gravity decreases, clear. So acceleration due to gravity, I can say this decreases with increasing depth, clear. And actually we are taking here an important assumption that we are taking that density of this earth is uniform, clear. Actually this formula is derived whenever we are assuming density of a earth that is uniform, clear. Okay, fine, complete. Now if I am talking about part number C, in part number C it is given acceleration due to gravity is independent of mass of earth or mass of a body. Now listen carefully. Actually we know force of gravitation, this is given by G me m upon r square, clear, where me is what, this is mass of a earth, and small m is what, mass of a body, clear, and r is what, it is distance between small m mass and mass of a earth, clear. Now or you can say r is a distance between a particular body and we can say earth, clear. Now if we can also write like this, let's suppose here we have this is earth, we are taking here mass me. Let's suppose here we have another planet, we can say another planet or satellite, any object. So and let's suppose it is having mass m and distance is given to you r, clear. Now let's suppose I want to find what is acceleration due to gravity act here, clear. So definitely we can say this object is actually revolving around the earth, so a centrifugal force will act towards center along radius, and actually that should be equal to G me m upon r square, clear. So we can say we can write here this value we are having mg, clear. So I can say we can write like this mg, this should be equal to G me m upon r square. Clear? From here we can say m and m, this one is cancelled out. Clear? So now we can write like this, value of g, this is given by gme divided by we can say r square. Clear? Now from this expression we can observe that acceleration due to gravity is depending only on a planet through which we are actually observing that gravitational pull. Clear? It means we can say that acceleration due to gravity, it does not depends on the mass of an object that is revolving around any object. Clear? It means directly I can say what is the correct answer of part number C. Acceleration due to gravity is independent of mass of, I can say, mass of body. Clear to everyone? Yes. Now we are going to discuss last part of this question. According to this part, the formula minus gmm 1 upon r2 minus 1 upon r1 is more or less accurate than formula mg r2 minus r1. Actually, this formula is given to you for change in potential energy. Clear? Actually, we know change in potential energy is given by u final minus u initial. Directly you can say this is mg r2 minus r1. Clear? But actually, if you are talking about accuracy of a formula, according to me, I can say this formula is more accurate. This formula is more accurate. Why? Because we can say final, this can be written like the gmem upon let's suppose rf minus, I can say this is plus gmem divided by r initial. Clear? Now we can say this formula is more accurate compared to this one. Why? Let's suppose an object is going at a certain height from the surface of earth. Let's suppose an object is going at a certain depth from the surface. Clear? At that time we will find there is a variation in acceleration due to gravity. Clear? So now we can say at a different location we will find variation in this value of g. It means I can say definitely there is a change in potential energy we will find. Clear? So according to me, I can say this formula is more accurate compared to this formula. Clear to everyone? So this is all about this question.